So today we're going to be talking about some additional topics in probability and countings, okay? The first thing we're going to talk about is something called a permutation. Now, a permutation is an ordered arrangement of objects, and the number of different permutations of n distinct objects is n factorial. So that's what that exclamation point means. It means factorial. This is how we found a factorial. 5 factorial is 5 times 4 times 3 times 2 times 1. So basically, we're starting with the number, and we're multiplying by all of its numbers below it, right? So you can guess that 4 factorial is just going to be 4 times 3 times 2 times 1, right? So this can be super helpful knowing these factorials, and they show up all the time. Example 1 says the objective of a 9x9 Sudoku puzzle is to fill the grid so that each row, column, and each 3x3 grid contain the digits 1 through 9 only once, right? So how many different ways can the first row of a blank 9x9 Sudoku be filled out? So it's interesting how many there is. So if you look at each one independently, let's say we start with the first, the most left square. So for that, if I'm going to use digits 1 through 9, I have 9 different choices it can be, right? Now, one of those choices is now gone. Let's say it's 9. I go to the next one. Now I have 8 choices for the next box. Okay, once that's gone, then I have, for the next box, I have 7. And you'll notice a pattern, right? You'll notice it becomes that factorial. And so we end up getting all the way down to the final box. There's only going to be 1, right? And so this is going to be 9 factorial. So that means there's 9 factorial different ways that I can fill out the top row of a Sudoku grid. So I look at that and I say, well, what is 9 factorial? Well, I have it written here. It's 362,880 different ways. So 362,880. So every time they're going to create a Sudoku puzzle, there's actually 362,880 different ways to start the first row, and you can go from there. So it's crazy to think how many actual different Sudoku puzzles can be created, because every row, barring some different, you have to take into account the grid and whatever else, but there's tons and tons of different ways. And this is actually a really, really good combinatorics problem that can be seen all over the place. Now, what is the equation for permutations? Okay, so right here it says the number of permutations of n distinct objects taken r at a time is this right here, n factorial over n minus r factorial. And we use this denotation, which is NPR. So n objects r at a time. Now, example 2 says this. Find the number of ways to form a 4-digit code in which no digit is repeated. So think about it. In digits, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? If you look at a keypad on a phone, there's 0 to 9. So there's 10 different objects, right? 10 different objects. And here it says we're taking a 4-digit code. So our n is going to be 10, and our r is going to be 4, right? And so we're going to set up our equation. It's going to be 10 p of 4, which would be 10 factorial over 10 minus 4 factorial, which would equal, or if we go to our calculator, we can actually do it. So we go to our functions, NPR, and we're going to be looking at 10, 4, 5,040. So if you wanted to make up a 4-digit code, let's say for your phone, and you didn't want a single digit to be repeated, there would be 5,040 different ways to do it, which is a countable number. So it is something that someone could figure out theoretically by trying every single permutation. Here's another one. It says 43 cars start the 2010 Daytona 500. How many ways can cars finish first, second, and third? So if we think about it, our n is going to be the 43 cars, and we're taking 3 at a time. So our permutation is going to be 43 p of 3, right? And so we look at this, okay? And we say function NPR. We're looking at 43 3. There's 74,046. So, of 43 cars in a race, different ways you can get first, second, and third place, there's 74,046 different ways. It's crazy to think that there's that many different ways when there's only 43 cars. Now, we're going to be looking at distinguishable permutations. It says the number of distinguishable permutations of n objects where n1 are of one type and n2 are of another type, and so on. It's basically when we're looking at different repeated things, right? Okay, so it says this. It says, finding the number of distinguishable permutations. A building contractor is planning to develop a subdivision. The subdivision is to consist of 6 one-story houses, 4 two-story houses, and 2 split-level houses. How many distinguishable ways can the houses be arranged? Okay, so think about it. N is total number of houses. So 6 and 4 is 10, and 2 would be 12, right? Now, there's 6 of one type, so we'll say N1 is going to equal 6. N2 is going to be the two-story houses, and N3 is going to be the split level, right, which would be 2. And so to figure it out, we're going to do this. We're going to say it's 12 factorial over 6 factorial times 4 factorial times 2 factorial. And so we can actually go to our calculator and figure this out. And so we're going to do that. So 12 factorial divided by, and then it was going to be 6 factorial times 4 factorial times 2 factorial. And it ends up being 13,860. So, although there's only 12 different types of houses, there's over 13,000 different ways to arrange those houses. Okay, so that's what permutations are. Tomorrow we're going to be looking at combinations.